Hi, we are Big Orange Design. We've been hard at work with faculty at the University of Tennessee to create an indoor testbed space to help enhance their research. As you all may know, the COVID-19 pandemic has forced us to re-examine how we view small space living. While the attractiveness of small space living can be found in its affordability and practicability, it may not always be in the best interest of the person's health. In our global society, urban spaces are beginning to diminish, and we have to find solutions to help balance the health concerns with the space limitations for individuals looking to move to urban spaces. Our aim is to provide a space for researchers to apply as many controlled factors as they need to help improve the health and safety of individuals in the space. In our design, we prioritize modularity, focusing primarily on interchangeability of the walls and floor panels.
Our team provided engineering services for the UT faculty. That included determining the location of the test bed, which was located in the auxiliary services building later. We also provided structural engineering services, and we designed the structure in a sustainable way that will affect the global industry eventually. We also provided construction engineering services that includes scheduling and construction management.
In order for our test bed to be as inclusive as possible, we have made nearly the entire test bed modular, meaning the floor, walls, ceiling, insulation, and HVAC can all be interchanged. And in order to provide different environmental setups, the humidity, lighting, air quality, and temperature will all be accurately controlled. But without a high quality monitoring system, none of that would matter. So all of those parameters will be monitored along with movement, video footage, and airborne pathogens. We wanted to make this testbed have as many open avenues as possible in order to accommodate a large range of possibilities.
The indoor testbed will be used to see the effects of temperature and humidity of wood panels commonly found in residential homes. The results will aid in improving building materials and the infrastructure of cities. The indoor testbed will also be equipped with sensors that capture air quality conditions that can be beneficial to health professionals. They can use this data to understand how human foot traffic can spread pathogens. The data gathered from the sensors is vital in advancing health informatics.
By working on this project, our design team has been able to improve on our critical thinking and problem-solving skills by working on the structural design, construction scheduling, and developing smart sensor applications for our indoor testbed. We have been challenged to accommodate different faculty needs and create design solutions. In addition to developing critical thinking skills and problem-solving skills, we have been able to achieve professional engineering outcomes of teamwork and project management throughout the design of our testbed.